we will discuss work energy equation. Work energy equation for gravitational field. I tell you one thing, always a work energy equation, take initial point as A and final point at B, then you will always have the one equation. Suppose if the body is going from A to B, then take this as the initial point and this as the final point. If suppose body is coming down, then take this point as A and take this point as B, so that we can always have the same equation. We say EP at A plus EK at A means potential energy at A plus kinetic energy at A plus work done on body. If it is positive, if work done will be by the body, if it's negative. The work done must be equal to EP at B plus EK at B. In work energy equation, there is no work done against the force of friction in this case, because usually there is no friction or resistance for the gravitational fields are concerned, because the bodies has to move very far away. So we have this equation. Sometimes this equation may be also written as work done is equal to change in potential energy plus change in kinetic energy. But change must be with the positive or negative sign. EP is positive when EP increases, and of course will be negative when EP decreases. Similar is the case, delta EK will be positive when EK increases, and it will be negative when EK decreases. In this equation, while applying this equation, care must be taken. You have to take the proper signs. Always for both, you have to take the proper signs. If it is positive, you have to take positive. If it's negative, you have to take negative. And similarly, for example, I can also say, suppose a body moves from here, and how you will be calculating delta EP? Actually, change is always calculated final EP minus initial EP. Keep in mind, always change is final minus initial. Any change is always final minus initial. When you take this thing, if it comes positive, then the quantity increases. If it comes negative, then the quantity decreases. But you have to stick to signs. Okay, so signs will be always taken in a way. Positive means it increases, and negative means it decreases. I can write one question, which is a very good question, to cover the circular motion, and also it will tell us how the work energy equation is used. A satellite, I'm taking a satellite of mass 600 kg is lifted from surface of Earth of radius 6.4 into 10 power 6 meter. Mass of the Earth is 6.0 into 10 power 24 kg. The height of the satellite is 36,000 kilometers. The time period of the satellite is 24 hours. Calculate work done on it. Now clearly we have to calculate the work on it. This is the Earth, suppose, and this is its radius. This is the gravitational field. A satellite of mass m 600 kg is brought up to here, this at 36,000 kilometers up to the surface of Earth. Now we have to find the work done. I can take, suppose, this point at A, this point at B. I can write one equation, EP at A. I can write this equation also, EP at A plus EK at A plus work done is equal to EP at B plus EK at B. That's very simple. So I'll be first finding, or I can use this equation. I'll be doing this question by both ways, and I will tell you that in the both ways the answer comes same. It's delta EP plus delta EK. So delta EP plus delta EK is the final position minus initial position. So I'll be taking the signs in account also for that one. So in both ways the answer will come same. So I'll first find what's the EP at A. EP at A, I can find it is minus GMM upon RE, because the surface of the Earth. Then I can put the values, minus 6.67 into 10 power minus 11, 6 into 10 power 24 into 600 divided by RE, radius of Earth is 6.4 into 10 power 6. I can calculate this EP at A, then it is 6.67 exponential minus 11 into 6 exponential 24 into 600 divided by 6.4 exponential 6, and the answer 6.67. Again I am writing, there was some error, into 6 exponential 24 into 600 divided by 6.4 exponential 6. It is coming out to be minus 3.752 to 10 power 10 joules. So EP at A is that. What is EK at A? EK at A 0. Of course, the satellite is at rest at that point. Now I'll be finding the EP at B. I have just find EP at A is minus 3.752 to 10 power 10 joules. EK is 0. I'll just find the EP at B. Now EP at B will be, I can write EP at B. EP at B will be, EP at B is RE plus 36,000 kilometers. Because you can see this rate, now this test becomes from the 36,000 plus this one. So if I write this minus 6.67 into 10 power minus 11 into 6 into 10 power 24 into 600 divided by, this will be 6.4 into 10 power 6, and plus this is 36 into 10 power 6. I can calculate these values. It is 6.67 exponential minus 11 into 6 exponential 24 into 600 divided by 6 bracket 6.4 exponential 6 plus 36 exponential 6 bracket over, and it comes out to be minus 6.66 into that cannot happen. Okay, I will be calculating 6.67 exponential minus 11 into 6 exponential 24 into 600 divided by in bracket 6.4 exponential 6 plus 36 exponential 6. Yes, now it is correct. It's coming minus 5.66 into 10 power 9. There was some mistake, I was getting 10 power 19, so it was not of the magnitude. So that's always the point. Always check the answers if they are reasonable or not. So this EP at B is minus 5.66 into 10 power 9 joules at this point. I'll be calculating what's the kinetic energy at that point. Now for the kinetic energy at that point, I will find the speed. I can find the omega angular speed by 2 pi upon capital T, and it is 2 into 3.142 divided by 24 into 3600. This R, so it will be changed into seconds. So I get now 2 exponential pi, 2 pi divided by 24 into 3600. It comes out to be 7.27 into 10 power minus 5 radians per second. This is the angular speed of the satellite. I will rather finding it now is linear speed because I need linear speed for kinetic energy. V is equal to R omega. R is the orbital radius, and orbital radius is 6.4 into 10 power 6 plus 36 into 10 power 6 into omega is 7.27 to 10 power minus 5. So this will be the linear speed coming. I'm just calculating. It is 3083 meters per second. So 3083 meter per second. See how I have calculated. I have calculated first the angular speed. Omega is equal to 2 pi upon T. Then I calculate V is equal to R omega. R is the radius, will be orbital radius is this height plus radius of the earth. So it is 3080 meter per second. It's 3080 meter per second. I can now calculate EK. EK is 1 upon 2 into 600 into 3080 whole square. So I'll be getting I get the answer 2.85 into 10 power 9 joules. So EK here is 2.85 into 10 power 9 joules at this point B. So I can now use this equation EP at A plus EK at A plus work done, this one EP at A. EP at A is minus 3.752 into 10 power 10 plus EK at A 0 plus work done. EP at B is minus 5.66 into 10 power 9 plus EK at B is 2.85 into 10 power 9. So work done will be equal to minus 5.66 into 10 power 9 plus 285 into 10 power 9. This is minus, it will come here plus. This is 3.752 into 10 power 9. Now 10 power 9 is common. I can just calculate minus 5.66 plus 285 plus 3.752. So I get minus 5.66 plus 285 plus 3.752. It is not 285, it's 2.85, sorry. 2.85. So it is minus 5.66 plus 2.85 plus 3.752. It is coming 0.942 into 10 power 9 joules, or if I wish, I can have 9.42 into 10 power 8 joules. This is the work done. So we can calculate the work done in that case. Always the equation is same. Even if you use work done is equal to delta EP plus delta EK, then you will get the same answer.